Okay, here we go. Properties of log. So just like we have exponent laws and rules for solving exponents and manipulating values, numbers with exponents, we have log laws or properties of logs that help us simplify and solve logarithmic equations and functions. Okay, so first thing we have to be comfortable doing is going from exponential form to logarithmic form. You need to be able to go back and forth relatively comfortably. If you still have issues with that, practice more, go back and look at the previous videos and try to sort that out, okay? I have a bunch of laws here. The first one, or the rules, the first one is what we call a product rule. Now I can give you a proof for this, but that would be a very long video. If you want a proof, come talk to me, we can sort it out. It's also actually in your workbook in this 4.3 section, okay? It derives or proves each of these four laws that I'm about to give you, okay? Now what this means is that you can go both ways, okay? So it means this: if I have log base 3 of, say, 20, well, let's not do 25, let's do 24, that could be log base 3 of 6 plus log base 3 of 4. I can break it down into 12 and 2 or whatever, 8 and 3, whatever I want, but this is an example of your product rule, okay? Notice they have to be the same base, all right? Now the next thing we're going to look at is what they call the quotient rule. Similar thing, right? If you are, well, remember, think about the exponents. When you have exponents that have the same base, right, you add the exponents, and logs are exponents, so we're adding the exponents. You can kind of think of it that way, okay? And when we divide with the same base, when we deal with exponents, we actually subtract the exponents. So it's kind of the same thing here, right? If I had log base 5 of 10 minus log base 5 of 2, that would be the same as saying log base 5 of 10 over 2, which would be log base 5 of 5. There you go. And what we're going to see very shortly is that we're going to be evaluating logs. Take a look at that and see if you can tell me what you think that actually equals. It equals a value. I'll tell you right now it's 1, because 5 to the power of 1 is 5. There you go. So this is how we can simplify logs. This whole thing ends up becoming that, which is 1. Pretty weird, kind of cool. Hopefully we'll get it sorted out. Now the next thing is the power rule. Now we know a power to a power, right, is a multiplication. And this is what happens. Look, power to a power, right? So boom, ends up being a multiplication. What happens is this: if you have log, let's just not even put a base, which means it's implying a base of 10, right? So log base 10 of 4 to the power of 2 would be equal to 2 log 4. And you can even do it differently, right? If I had log base, how am I going to do this? Base 2 of 8. Okay, well, how can I simplify this? Well, maybe I could turn the 8 into a base of 2. That would be the same as saying log base 2 of 2 cubed. And now this power law means that the 3 is going to come out log base 2 of 2. And we just kind of look at this being 1, so this whole thing is 3. So log base 2 of 8 is actually equal to 3. Kind of weird, I know, but you're going to have to do tons of these to get comfortable with them, okay? The next thing we have is a change of base. And the reason we have a change of base is because if you look at your calculator, okay, all it has is log and natural log. And we're going to deal with those pretty quick here, but when they only have log, it means they deal with base 10. So what you have to do is figure out a way to turn things into base 10. And it just so happens that if you have, for example, log base 2 of 7, right? So log base 2 of 7, that's basically equal to log base whatever you want of 7 over log base whatever you want of 2. Now I can choose any base here. Okay, you can convert it to any base. What we like to do is convert it to base 10. So then I can just do it on my calculator, right? Then I just end up going log 7, enter, divided by log 2. And you end up with an answer like 2.8. Okay, so you can solve these things by changing the base to base 10, which is what you want to deal with on your calculators. And we'll deal with natural logs too. You can actually do ln7 over ln2, but that's a completely different, not a completely different story. This just deals with natural logs that maybe you haven't had a lot of exposure to yet, okay? So here we go. Let's move on here. Here's a few helpful rules, okay, that I'd like you to think about. Let's start with these up here. First of all, any base, if you've got it equaling to 0, I mean, this is just a situation, right? So b to the power of 0 is equal to 1. So if you ever have a 1 here, log base anything, log base 19, 1, that's got to be 0, because anything to the power of 0 is 1, right? Okay, so now the next one. B to the power of 1 is b. So in this case, right, this is what we saw in those previous examples. If you have a log base 5 of 5, that's 1. If you have log base 17 of 17, that's 1. That's the beauty. It makes it a lot easier to solve. Now, ln e equals 1. The reason we have that one there is because we're going to see natural logs occasionally. There's another video that explains natural logs, but the natural logs are basically used for continuous growth. Most natural situations, okay, deal with natural logs. It's just a base that ends up working. It's bizarre. Anyways, bam. So log base e is equal to ln. Okay, so if you have ln e, that's log base e of e, which is 1. Okay, that's the other thing. So now, here's a couple other, what do you want to call them, situations on the other side here, right? We can prove these as well. If you think about the change of base, right, that's going to be log x over log b. And if you go 1 over log, yeah, well, you can do this conversion into that. I can do the proof for you there. This one's kind of the same because we know that 1 over b is equal to b to the negative 1, so that's how we get the negative in front here. But write these down, have them on a separate sheet maybe to help you understand and help you solve a lot of those log equations that we're going to get, all right? Now here is another situation, and it basically says that if x equals y, then log bx equals log by, which is another way of saying that if you end up with a situation where you have this, okay, you can tell me that x is equal to 2. That's how we're going to solve this, okay? That's what this basically means. If you can make a log same base on either side, it means that those things are the same. And that's essentially what we're doing with exponential equations too, right? If I have 5 to the power of 3x is equal to 5 to the power of 6, you're going to tell me that x is equal to 2 because 3x is equal to 6. You equate the exponents. Here we equated the logs, okay? So we're trying to make some connections here, trying to show you that these things make sense, and you need to grasp them in order to solve these things that we're going to be dealing with very shortly, okay? Here's a couple more. This is just a weird one. If your base is to a power of a log, and the base of the log is the same as the base here, then it's just that number is what you're looking for, okay? This, again, deals with the concept that b1 over b is equal to b to the negative 1, okay? And this one over here states simply that these need to be positive. And if it might be a little confusing to think why. The easiest explanation is if you think of a graph here, okay? Your x is always positive, okay? Your x is always positive. Now your b and your y, yeah, you can have a negative y, okay? But your b, if it's negative, it's just kind of a weird thing. Let's accept it for now, and then we'll see why the base can't be negative either, okay? It's because if it's a negative and there's two negatives, you just make it a positive. But anyways, we'll sort that out in a bit. And this is what I want you to get from that. You can't take the log of a negative number. Basically, the most importantly is that x cannot be negative, okay? So these are a lot of laws here. There are a lot of rules, okay? A lot of rules, a lot of laws. The only way we're going to get through these is if we actually look at a bunch of them, okay? And what we're going to do is we're going to start off with, so keep those logs. Hopefully you wrote down those answers or those things, so have them in front of you when we're looking at these, okay? It will help to understand how these work. So this is an odd question that a lot of people have difficulty with. Right, each logarithm in terms of log 3 and log 5. So you want to break this down into log 3 and log 5, right? So what we do is we look at this and remember that you can break it up into its two factors. So log 9 plus log 5. Why'd we choose those? Well, it's a logical choice if we're trying to make 3 and 5 here. We already have a 5. How do I make a 3 here? Well, that's going to be log 3 squared plus log 5. And we know that the 2 can come up front, so it's 2 log 3 plus log 5. That would be how we simplify this in terms of log 3 and log 5. Okay? Now there's going to be other ones too, and we got to divide, and that's going to be subtraction, like this one, for example. So this is going to be log 25 minus log 3, okay? Which turns into log 5 squared minus log 3, which is 2 log 5 minus log 3, okay? So we're getting closer to figuring a lot of these out. Now, find exact values. Okay, well, this is where we need to be able to convert to exponential form, 7. Well, first of all, I guess, maybe you need to remember this, that this is the same as saying 7 to the power of 1/4. So you know what, I don't even actually need to convert this into logarithmic form or into exponential form, because the log law here shows me that this is going to be the same, that's just a 1, right? So the answer to that is 1/4. Now, I could convert this into exponential, but why bother, right? I mean, it would get the same thing. It'd be 7 to the power of x is equal to 7 to the power of 1/4, and then you equate the exponents. So there's more than one way to do these things, guys. Hopefully you'll be able to sort some out. So here we go. Find exact values. What the hell do you think we can do with this? Oops, sorry, didn't mean to say that. 6 comes down, boom, 6. Log base 5 of 5. Minus, the 2 can come down, 2. Log base 5 of 5. And I'm hoping that you can see that this is a 1, that is a 1, so you get 6 minus 2, which is 4. Okay? These are simple ones just to exemplify the ideas and the concepts. If you look in the book, obviously they'll start easy and they get harder. Expand. What the hell is this? Okay, so expand this. This is a little bit more harder to evaluate. You can break it down into a series of logs that make it easier to work with, right? So this is going to be the same as saying log base 5 of 3x to the power of 4 minus log of y squared. Now, this one can be broken into log base 5 of 3 plus log base 5 of x to the power of 4 minus log, where am I here? Log base 5, I forgot the base 5 there, of y squared. And now the last step would be just to expand it all. That 4 can come down, right? So it's 4 log base 5 of x. And that 2 can come down. That's 2 log base 5 of y. And you've just expanded it. And each of these, look, you can get a number there. You can, and your x and y are split up here. So it's a little bit easier to deal with when you expand it, okay? And conversely, what you're going to want to do here sometimes is condense them. So turn this back into something like that, right? Notice that they all have base 10, right? So let's deal with this. This is going to be log x to the power of 1/3, okay? This is going to be log x minus 1 to the power of 2. Tricky. Is this something that you can deal with? It's not. You can't expand this the way we did before. You can't go log x minus log 1. It's not the same, okay? This is a value that you're taking the log of, so it remains like that, okay? Last thing we can do here maybe is convert this x to the power of 1/3 would be the cube root of x plus log x minus 1 over 2. Oh, and you know what? I can even go further. It's the same base here. The idea is that I can go further, right? So this is going to be log, it's going to be the cube root of x times x minus 1 squared. You just put it all together, okay? All right, so we're getting closer here. What we're going to have to look at are, we're going to look at change of bases again. And before I look at change of bases, okay, we need to remember this, that if you only have log x, that means log base 10 of x, okay? That's what we call a common law. We also have ln x, which is what we call a natural log. That's log base e of x, okay? So these are the two buttons that you have on your calculator. You have a log button and an ln button, okay? And that's for these two logs, these two bases. A a common log, and a natural log. Now the issue is you don't always have a nice base of 10 or e. So what we need to look at is how do we calculate other bases. I gave you a taste of this a little bit ago, and it's really not that hard. Simply here, log base 712, you break it down in a logical pattern. The base goes on the bottom, the other one goes on the top, and you have the power to choose any base that you want. We didn't write a base, so it's base 10, but I can also choose a base e, which means it would be ln 12 over ln 7. You can do both, right? Regardless. Watch this. Okay, we're going to go, let's turn it on. We're going to go log 12 divided by log 7. Boom, there we go. I'm going to go ln 12 divided by ln 7. Boom, you get exactly the same answer. Okay, so it doesn't even matter which one you use, but that's basically it. This one, same thing, no big deal. Log base 10, 532 over log base 10 of 6, and you just do the multiplication or do the division. No big deal. Okay. I just left this here. We've already looked at that, right? That means that log base e of e is 1, right? Okay, let's go down here. We're almost done. So let's have a look at this. So there's a basic premise of fractions here, okay? If I have 1 over x, y, that's equal to y over x, right? I'd like you to think about that when I write this out. So this is going to be 1 over log 10 over log 2, right? Plus 1 over log 10 over log 5, right? Which means that this is going to be equal to log 2 over log 10 plus log 5 over log 10. Oops, log 10. That's 1. That's 1 because log 10 is log base 10 of 10, which is 1. So this is simply log 2 plus log 5, and you can solve it from there, right? No big deal. Oh, actually, we can go even further. Check this out. This is log, you're adding, so it means that it's log base 2 times 5, which is log base 10 of 10, which is 1. So this whole thing here equals 1. Pretty kooky, man. Pretty kooky. Okay, last one. I promise this is getting pretty painful. I can see that. But let's check this out. So I've got 6 log x. Let's do this. You can put the x up, the 6 up there, but what's it's going to end up being is 6 log x over log 9 minus 12 log x over log 27, right? If we simplify it now, it's going to be 6 log x over log 3 squared, right? Minus 12 log x over log 3 cubed. Oops, oh no, we're still there. Sorry, I thought I didn't have you anymore. We're almost done. I know this is pretty painful, ladies and gentlemen, but it's actually kind of cool once you get the puzzles going here. So the 2 can come out front, right? Minus 12 log x over the 3 can come out front, 3 log 3, right? Dig it. Now we can choose whatever we want. So this here, look, that becomes a 3. So now you have 3, and you can do it. Oh, this gets pretty crazy here. Let me see if I can slow down here a little bit for you. Hopefully you guys are still with me at this point, okay? And what I'm going to do is I'm going to show you that this simplifies to a 3, and now I have log x over log 3 minus, this becomes a 4, that becomes log x over log 3, okay? Now don't forget that just because the change of base thing here, look, if I'm here, I can get to this. Well, can't I go from here to here as well, where the bottom one becomes the base and the top one becomes there? So the bottom one becomes the base, so it's log base 3, and that goes up there, minus 4 log base 3 of x, and we're almost there, right? So what else here can we do? If I am subtracting with the same base, let's see what else we can do here. I can go log base 3 of x cubed minus 4 log base, sorry, not the 4 there, minus log base 3 of x to the power of 4. So now this is going to be log base 3. We're dividing x3 to the power over x4, right? So this is going to be log base 3 of x to the negative 1, which is negative log base 3 of x. Holy moly, patchouli. Right? So it's this manipulation that is going to solve your logarithmic functions and equations. So yeah, this is a little bit complicated. Hopefully you can follow through it. I will definitely do more examples in class.